Hello, Rallis team. I'm hoping that this helps explain what I was trying to convey with this proposal. So in this scenario, we have a 10,000 hectare area. We have two regions or pre-strata. One is 4,000 hectares, one is 6,000 hectares, which are the different colored rectangles. In these subpopulations or pre-strata, we have a CEO sample, which are all of the dots. A subset of those CEO points are ground plots, and those are identified as red dots. So in this example, in the blue 4,000 hectare stratum, we have a total of 9, or capital N sub H is 9, and we have a capital N sub H for the orange 6,000 hectare stratum as 6. Small n sub H in this example is 5, and in this example is 2. And these could have different intensities of CEO and or ground plots in both of the pre-strata / subpopulations. So in on this plot, for example, the CEO labeled it as FT1 or forest type 1. This plot was labeled as forest type 2, etc. Some of the plots are labeled as NF or non-forest. So there are 3 potential strata. We have on the ground plots measurements of megagrams per hectare of carbon. So in this example, it was labeled with CEO as forest type 1, and the ground measurement is 18 megagrams per hectare of carbon. Here we arrived, it was still forest, but there was no carbon for some reason. Perhaps the trees were too small or didn't meet the diameter threshold or whatever. Here we have 13, etc. On non-forest plots, we don't measure any trees in this example. So to get the estimate of area of each of the forest types for national reporting or for inventory reporting, we use simply the pre-stratification estimators, because we have what we're assuming is a random sample, even though it's a systematic sample, and we implement a weighted average and the weighted variance using the procedure described here. So for example, 3/9 is the number of points that are FT1. This point is FT1, this point is FT1, and this point is FT1. 3 of the 9 are FT1, thus the estimate of the proportion of FT1 is 3/9 times 0.4. 0.4 is 4 10,000ths of the area, or 40% of the area, which is the weight. In the orange stratum, we have 2 of the 6 points are FT1, this one and this one. So that creates 2/6 as the proportion, times 0.6 is the weight. So this weighted average, or this weighted proportion, is the estimate of the proportion. We take that weighted proportion times 10,000, and that's the estimate of the area of forest type 1. For the variance, we simply, you could do it with a binomial, or you could do it this way. Label each plot as a forest type 1 or not, a 1 or a 0. We could take the variance of the 3 points combined with the other 6, 0.25. These are the 2 points we discussed, 0.27, and then we use the squared weights and then divide by the sample size in each stratum to get the variance, the weighted variance of the overall proportion. So for the non-forest inventory, or National Forest inventory estimates, it's a different design. It's not treated as just a simple random sample. We're using double sampling for post-stratification. The CEO assigns all of the points, all of the elements of the sampling frame, one of those 3 strata, for FT1, FT2, or NF. We label each of the ground plots with the CEO call, so we know basically the stratum proportion, the stratum weight from the CEO calls, and we know the stratum identity from the CEO calls for the red ground plots here. and then we can implement the estimators, as I've shown here. I've tried to color code them so that you can kind of see in the equation which is which. FT1 is 18 divided by 2. Well, where do we get 18? 18 is, and again, this is just for, we're getting the mean carbon per hectare in each of these strata, and for just the blue region here. So we'll say the first stratum is the FT1 stratum. So here we have 18 plus 0, right? So that's 18 divided by 2 times 3/9, because the weight of that stratum is 3/9 of the entire stratum is the FT1 stratum, plus 13 divided by 2. So we have, let's see here, 13 plus 0 divided by 2 times 4/9, because there are 4 FT2 points in the stratum, 1, 2, 3, 4, plus 0 divided by 1, because in this very simple example, we only have one ground plot, which is a non-forest stratum, and there's only one of them, so 0 divided by 1, which ends up being 0, but it turns out that it's 2/9 of the area. So basically 2/9 of the area gets a value of 0 carbon. So we add all those together using this equation, and we get the total estimate of the proportion. I'm sorry, the estimate of the total amount of carbon per acre, which we can then multiply by 10,000 and get the total, the carbon stock, if we wanted to do it that way. Anyway, the variance is obviously, I'm not going to try to write out the variance here, but it's the same idea. The only thing we need to remember is that the big N is, the capital N is the number of elements, and the small n is the number of subplots in each of the H strata. So that's it.